Hey, thanks for having me. I hope you can see the slides that I'm trying to share and not my presenter view with all my notes. Um, and yeah, this is the last talk of the day, so I will try to make it as entertaining and as energized as possible so you guys can hopefully catch the last closing notes as well after. So yeah, I'm going to be talking about threat modeling for detection and response. Let me just make sure. Okay. Okay, cool. So apparently all is good. All right. So I'm a security engineer on the detection and response team at Cloudflare. And I am based out of San Francisco. So right now my local time is 6:30. So if I have any word mishaps, just attribute it to the early time. But yeah, some of my teammates also just gave a talk at DEF CON and BSides LV on some of the engineering work that we're doing. So I would recommend you guys check that out. All right, so first I'm going to get into an intro to cloud. We're building a global cloud network to help the faster, more secure, and more reliable. So Cloudflare is an internet company that offers network performance and security solutions for websites and teams. We have over 25 million internet properties that are using our services. 200, we operate in 200 cities and in 100 plus countries. Every single day we have 87 billion cyber threats that are blocked, and we have over 2,000 employees all over the world, and 99% of the internet connected population in the developed world is located within 100 milliseconds of our network. So hopefully as more of the world gets connected to the internet, we can be closer to serve them. So to run this vast network, we need many different tools and services. So here's a list of some of the engineering tools that we use to run Cloudflare in the backend. There's a lot of data that's exchanged between these services that enable our network to run efficiently. So how does a security team protect it all? We do this by having a wide range of responsibilities that span across all of these functions. But in order for us to be proactive about protecting these services effectively with engineering teams, to understand the risks that exist in our services or architecture, authentication changes, we need to really have a good relationship with them. And one of the ways we do that is through threat modeling. So I'm going to give a quick overview in case people in the audience haven't heard of threat modeling, or they haven't actually done it in a production environment and have read about it, but they haven't actually gotten an opportunity to do it at work. So most threat model frameworks out there, regardless of the methodology, generally have these goals in mind. And it really, I'm not going to go over all the points on my slides, but it really boils down to risk management, identifying vulnerabilities, and prevention of exploitation through bug fixes. So the general approach includes answering some of these questions, right? You could be assessing APIs, your cloud environment, GCP, AWS, or you could be assessing certificate management and how the service authenticates to other services. So you're also looking into where things can go wrong. You could be dealing with over-permissive users, mismanagement of keys, or even hardware-related vulnerabilities. And how we generally try to address them is through documentation, which sounds unintuitive, but it's really true. When security teams identify all these vulnerabilities, the engineering teams aren't able to prioritize it yet. So the best thing we can do is add it to a backlog and make sure it's documented somewhere, add in detections, and obviously clean up code. So here are some of the general steps, and these are some of the common frameworks that some of you may be familiar with. So the first step is the planning phase, and this is where you scope out the threat model and try to figure out which part of the system you're going to be focusing on, and Sometimes if you haven't touched a system at all, it could just be a combination of everything in a high-level overview. The next phase usually involves identifying, which is identifying and classifying the types of threats that you may be exposed to after you've done the planning and assessment. Third is prevention and mitigation. And this is where you typically identify threat and risk mitigations and tools and processes and bug fixes as well to prevent exploitation of the risks that have been found. And finally, it's validation and remediation. So you've done all the mitigation, and now you want to make sure that it's actually covering the risk that you've identified. And I feel like these last, honestly, all these steps are iterative, and you revisit them every once in a while, hopefully, ideally. And I'm going to be focusing on the prevention and mitigation steps. So I'm going to be talking about methodology that can help security teams, but in particular, detection and response teams effectively involve themselves and detection and response principles into threat modeling to be more proactive and to make the most of the process. So if your team is too small to have a dedicated function just for detection and response, then you can think about all of the things that I'm going over in terms of someone advocating for DNR principles. And some of the things I'm going to be describing may be like, it's going to be describing a lot of like how it's done at Cloudflare, but the approach may be varied based on the company and the security team. So it's supposed to be flexible around that. So the role of detection response is usually not something that people think about in my experience in threat modeling, and different factors impact a security team's priorities and ability to prioritize DNR goals. Usually it's product security and application security, right? Like if you identify a bug during threat modeling, are you really going to be worrying about like logging and auditing, or do you just want to fix that bug and then deal with like the 20 other things that are going on? So teams may run very lean and prioritize fixing bugs as opposed to proactively detecting bad behavior, which is understandable, but it isn't to say that noting down risks or building a backlog to help detect malicious behavior wouldn't help in the long run. So like I said, different teams have different priorities and perspectives, and in my experience, product security and application security usually have the principles of fixing vulnerabilities, and they're usually the first ones to come in to evaluate a system to understand what risks and software vulnerabilities exist. They generally seem to be focused on the foundational principles of confidentiality, integrity, and availability. And when you think about authentication, architecture, these kind of map back to CIA. So product security teams typically get embedded into the SDLC process and are included for security reviews when features are added. And even minor changes could actually introduce really troublesome security bugs that developers may not think about. So when security teams, typically lean ones, actually may want to reduce the amount of logs that come in for an application. So this is where detection and response teams, I think, come in, because we want to prioritize adding in the feature of auditing for our systems, so that even once the security bugs or vulnerabilities are addressed through code reviews, we can make sure that we have detections in place that can identify the underlying actions that may point to a new bug or a new fix. And security handling or product security teams, because they may deprioritize logging, they can actually, it's a give and take, right? Like different teams are going to be prioritizing different things. So this is why it's important to have different perspectives involved in the threat modeling process. So let's say you're at a company now and the security team has different functions and they're ready to think about involving DNR. So these are the scenarios that I found to be very useful to involve detection and response teams. Essentially, I would describe the scopes as being focused on, security feature changes, infrastructure changes, logging, auditing, and major modifications to user permissions and access. DNR engineers want to know if they can detect these changes and if they're enabled through auditing and logging to be able to detect them. So now I'm going to go into a framework and how DNR engineers can get the most out of the threat modeling session. So let's say now you're included in the sessions and you want to know how to make the most of it. So how do we prioritize what we need to focus on? There's a lot of different tools and different services that are operating in a production environment. And so there's different types of risks per area. So I would say something that's really helped me is using a data-centric risk evaluation. So, where is the most sensitive data located? How can that data be exploited? Think about attack vectors and traversal paths through your environment. And attacker trees is something that's mentioned in a lot of threat modeling methodologies. So I'm not claiming that as mine, but not a lot of them have modernized it in the sense of there's a lot of frameworks out there like the attack matrix that help detection and response. Engineers think through the types of exploitations in a more structured format. And a lot of this can also vary based on the culture of your company. It could be that your company really wants to focus on where customer data is located, or maybe they're in a phase where they really want to deprioritize customer information for this quarter, and they want to focus on insider threats and employee data. So these are an overview of areas to review when you're trying to prioritize which service or system to look into. So the first one is authentication. Some of the questions that I've thought through in the past is, how does authentication to the service work? Who or what services has access to this system? And who or what controls access to it? So it could be very much a process-related vulnerability or gap where one person has the ability to grant access to engineering teams to a data store. And then who is able to make changes to this data? Next is storage. So you want to think through what platforms store this data, where is it forwarding data to, and where is it getting data from? Think about how long that data is stored and who has access to this data in the data stores. A lot of this can be, I guess what I want to say is when companies scale really fast, a lot of this can be rushed through because they're trying to get things to work and they're trying to meet very, very quick and tight deadlines. So a lot of this may not be as secure as you originally think. So 2 more areas. Logging. So what logging and auditing is available to monitor for anomalous activity, and what logging should be implemented? And is our logging pipeline set up in such a way that we can ingest the available logs? So my intention with this point is, like I said in the last slide, a lot of engineering teams, if they had to scale really quickly or if they had to get things pushed into production really quickly, they don't really prioritize adding in logging into like crucial interactions of a system. So the thing you want to think through here is, are we logging the interactions that we consider to be the riskiest in how a system is run? And if your detection and response team is aggregating all those logs into a SIM or some other tool, then can we ingest those logs in a way that enables us to build detections on it? And one other point to say about logging before I go into the next one is sometimes logging doesn't even exist, right? So it's not as simple as, okay, that's something that we need to have. Engineering teams need to be able to prioritize this and maybe even add it into their backlog so that they can commit to generating logs. So the 4th point is service-to-service interaction. So how do other services interact with this one? What type of customer information does it interact with? And then, does the service interact with customer data? So service-to-service interaction means what kind of downstream and upstream services is it exchanging data with, and what kind of information is it sending to these other services. Maybe we want to detect when it sends a wrong kind of data point, or if it allows for user intervention and users to manually push different kinds of data in, can we detect that? Right, so another important aspect of threat modeling is to take on different perspectives. So imagine you're a red team, like what would an attacker look like in this environment? What are some of the ways you can exploit it? Next is blue team. What could we use to validate detection of specific adversarial techniques? And the third point is insider threat. So intentional or not, what is possible given the amount of access that a user or service is given in this application? So internal threat actors and different access points. We want to make sure that a internal user that has permissions to interact with the system is also something that we're all logging and making sure that we can identify those malicious behavior. So there's an attack navigator tool that the attack matrix framework has released, and that is used to think through like different attacks in a system. They have it for Mac, Linux, and Windows, but then they also recently released an attack defense matrix, and it's used to identify detection techniques that could apply to your environment. So they have different techniques that list out the different kinds of attack vectors or techniques that they map back to. So it's kind of like a two different sides of one coin sort of thing that I think I found to be very useful when I've threat modeled in the past. So long-term benefits of threat modeling. Again, you can track items flagged as risks. So even if as a detection and response engineer, sometimes it takes a long time for something good to happen. And a lot of the times you're relying on the system owners to enable our work, right? We may not be the subject matter experts on a system, but as long as we are able to effectively track these items as risks, we can work with the engineering teams in the long term to enable our objectives. It's collaborative and iterative. The goal isn't to threat model a system that one time and then forget about it. Ideally, you're going back, as new features are added or crucial features are modified, or when a new system is developed, engineering teams know who to reach out to, and they're familiar with working with your team. And so this really is a process and culture-driven thing as well. So distributed approach to scaling threat modeling. It sounds like a fancy little phrase, but it's really just trying to describe the different teams that are involved in a threat modeling session. So if you have different security teams that you want to include, if you want to have different engineering teams included in it. So it's not just a detection and response engineer's responsibility. Like you need to help people feel like they have skin in the game when they're working on this. Start small and then expand. If this is not the first time you're looking at a system, or at least people have a general understanding of it, then you can pick on a specific part of the system and then just threat model that. Like maybe you just want to focus on authentication, because I feel like authentication is one of those things that it sounds pretty simple when you think about it, but there's a lot of different things that go into it, like certificate handling, the process of getting authentication, the granular access, like permissions, and who controls all of that. So ideally start small and then expand the scope of the system that you're threat modeling. And then collection of audit logs. No one really loves to work on, I think, certain things just for compliance. So, I think this is a point that would help the long-term objectives of detection and response. And so once you have a system that you've identified that doesn't generate logs, and you're able to work with engineering teams to actually implement it, then that's a huge win, in my opinion, that you can build on in the years to come to make sure that you're enabling the DNR team. Work with engineers to adopt better auditing. I think I've spoken this point to death at this point, but yeah, making sure that engineering teams know that auditing is not just for debugging, that there's benefits to certain kinds of audit logging for detecting malicious behavior. And then documentation. This goes into engineers, and when people leave the company, things may not be documented as thoroughly as you'd like, and then you have a new member coming in who may need to start from scratch, and which isn't ideal because you've just lost all of the benefits of the months-long process of or work that this previous person has done. So it's pretty important to make sure that you've documented your findings pretty clearly. Okay, stakeholder engagement. So system owners that know the ins and outs and historical context. Like I said, a lot of times teams have to scale up really quickly and then just get things out of the door. And so that knowledge could be concentrated in one or two people that are at the company and not really documented or shared anywhere. So it's really important to build good relationships with them and make sure that they're involved in this threat modeling process as well, because ultimately they're going to be able to influence the roadmap in case you need to have asks for the engineering teams. Application security. So this is from the perspective of detection and response. You want application security and the other security teams, to be honest, involved in the threat modeling process, because it's, like I said, a very holistic approach. Ideally, it wouldn't just be product security or application security that's doing threat modeling. It wouldn't just be DNR engineers as well. And then partnering with engineering teams. So obviously start small and then expand. You don't want to just be heavy-handed with implementing a partnership program with engineering teams. You want to make sure that you've tested the process out with one or two teams, and you identify what works and what doesn't work, how people like to be engaged, understand how the security org in your company prioritizes tasks, and think about the larger themes that are happening at the company, right? Like, you need to be able to, it's a give and take. You can't just expect them to prioritize our asks because we're a security team, and obviously security is the most important thing. I'm biased, but yeah. Agreed upon timelines for any auditing implementation. At Cloudflare, at least for us, what's worked is if there's business needs and external needs outside of the security team that are also helping us ask for an implementation and auditing, engineering teams are quicker to get to it, but that's not always the case. They have their own priorities, their own quarterly goals and everything going on. So make sure that you're able to negotiate a timeline for when they can implement it. Otherwise, you can go quarters and quarters without really being able to really know what's going on in a system, and it's just going to be like a black hole. Right, so we're in a remote world now, pretty much. So how do we prepare for a remote threat modeling? Create and send out diagrams and pre-meeting material. What this could mean is you can use the existing documentation, existing information out there about a system to go and then read the code that your company has implemented to run the system, and try to create diagrams and a general understanding of your understanding of how the system works, and make sure that it's available for everyone who's involved in this session. The benefit of that is, one, it leads to a general understanding of the system, and then you also have done some proactive work and are not asking the engineering teams or the system owners to explain everything to you, which is the quickest way to get them to not really want to do it again, because who has that kind of time, right? And I think something else that helps when you have multiple teams involved is a general understanding of who should focus on what. And this is more of a cultural thing, and this is something that can vary between teams. But if you want a certain team to focus on one aspect of the system, and then you want another team to focus on another one, it can really allow those engineers to dive deeply into those topics, as opposed to everyone working on everything and then slowly making progress in each of those pillars. You can have specialized engineers working on very specific things, but obviously this could vary depending on the size of the team and the amount of resources and time that you have to dedicate to this. So define scope beforehand. Ideally, you would know if you're trying to do a high-level overview, or if you're looking into a specific aspect of it. Speaks for itself. And then again, explain or share foundational knowledge, tribal knowledge, and unintentional knowledge, like hoarding, basically can really lead to inefficiencies in an organization. So, I would encourage you, if you're the one that's leading the session, to really make sure you document and capture what you've found in an effective way, so that someone that's reading your threat model document can almost pretty much be at the same place that you are after having spent X amount of time on it. And that, I think, is a win. Well, that's the end of my talk. So thank you for joining. This is my email at Cloudflare. My LinkedIn is also attached there once the slides and recordings are out. And there's a link to Cloudflare jobs if anyone is interested in joining our team. And I also want to say special thanks to 4 of my teammates that have helped me with this presentation.